Okay, today I'm going to be covering some red and black tree insertion operations. If you remember, the properties of a red-black tree are every node is either red or black, the root is black, and every null node is considered black. And if a node is red, then both of its children are black. And every simple path from a node to a descendant null node contains the same number of black nodes. So remember when you're inserting a node that the node is initially red, and there's 4 cases outlined for the fix-up procedure, and the case that you're going to execute depends on the color of the inserted node X's uncle and whether the inserted node is a left or right child. And for the rest of this video, I'm going to refer to the node that we're inserting as node X unless otherwise specified. So for case 0, you have X as being the root if you insert into an empty tree. Case 1 is X's uncle Y is red. Case 2 is X's uncle Y is black, and X's parent is the left child and X is the right child. Or X's parent is the right child and X is the left child. And then case 3, we have X's uncle Y is black and X's parent is the left child, as well as X being the left child. Or X's parent is the right child and X is also a right child. And the difference between case 2 and 3 here is whether or not the parent and the child are both left children, or both right children, or opposite of each other, where one's left and the other's right. So if we insert into an empty tree here, the node 12, it's going to be case 0 where X is the root, and then the way you fix this is you're going to color the node black, and then you're done. And then if you go on to insert 9 and 15 into this structure, there's no properties being violated here. Remember that the null nodes that I haven't drawn here are considered black, so these both have 2 black children, the same number of black nodes from root to leaf, so there's no fix-up to be done here. And then if we insert 7, we have a problem, remember, because we require that red nodes have 2 black children, and now we have a red node with a red child. So we have to perform a fix-up here. And this is going to be case 1 because X's uncle Y is red. And the way you're going to fix this is you're going to color X's parent black. You're going to color X's uncle Y black. And then you're also going to color X's parent's parent. I'm going to refer to that as X's grandparent. You're going to color the grandparent red. And then we're going to set the node 12 to be X because we're going to set X equal to the grandparent. And then step 5 says, if your new X's parent is red, then you're going to proceed to the appropriate fix-up case. If your new X is the root, go to case 0, and otherwise we're done. In this case, we have X is now the root, so we're going to go to case 0, and if you remember, then the only thing we need to do is color the node black, and now we're finished. And then if we insert 5 from here, this is going to be a case 3. I drew this null node here just to help with this example. Remember that null nodes are considered black nodes, so case 3 says X's uncle Y is black. Even though it's a null node, it's still a black node. And if X's parent is the left child, then X is the left child, which is what we have here. X's parent is the left child of 9, and X is the left child of 7. So again, this null node is just to help you understand this example. You don't need to represent them, but in this case, I feel like it's helpful. So the way you're going to fix this is you're going to color X's parent black. You're going to color the grandparent red. And then if X's parent is the left child, you're going to right rotate the grandparent. Otherwise, if X's parent is the right child, we're going to left rotate the grandparent, and then you're done. So in this case, we're going to be right rotating because X's parent is the left child, and you're going to end up with something like this. And now we're done. This is what the graph would look like, or the tree would look like with without the null node here. Either representation is fine. Again, I just did the null node to help with the example and identifying which case we're using. Okay, so then if we insert 13 into this tree, there's no violations here, so there's no fix-up to be done. But then if we go on to insert 14, we have case 2. Again, I'm going to draw this null node here as being black just for the example's sake. I feel like it's helpful. So in this case, we have X's uncle Y is black. Even though it's a null node, again, it's black. And then if X's parent is the left child and X is the right child, which is what we have here, X's parent is the left child of 15, and X is the right child of its parent. So the way that you're going to fix this is you're going to set X equal to its parent. So now we're going to call 13X. And if X is the left child, we're going to left rotate X, or if X is the right child, we're going to right rotate X. In this case, X is the left child, so we're going to be left rotating. And then we'll end up with this structure. And this is still a problem because, again, remember, red nodes need to have 2 black children, and we still have a red node with a red child. So the way to fix this is we're going to now proceed to case 3. And case 3 we're going to solve the same way we did in the previous example. We're going to color X's parent black. we're going to color the grandparent red. And then if X's parent is the left child, we're going to right rotate the grandparent, which is the case we have here. Otherwise, we would do X's parent as the right child, we would left rotate the grandparent. But again, we have a left child situation, so we're going to right rotate. And then we would end up with this. And we're done. And then here's, again, the tree representation without the null node. Either one is fine. Again, I just did this for the example. Okay, and this I'm not going to solve in the video. I'm going to leave this up to you. I feel like it'd be good practice. So I will include the slides for this question. I do go over how to solve this step by step, similar to how I did above or the previous examples. I'm just going to leave this as an exercise because I feel like it's good practice. But the solutions and the steps are in the slides. So maybe if you want, you can, work this out and then compare what you do or what you end up with to the solution in the slides, or if you want to work alongside them to make sense of it, either one is fine, but I'm going to leave that up to you. So hopefully this helps.